Hi, I'm Kai. Now I'm going to do the question 2 of homework 6 for probability and stochastic processes. So on the question 2, f xy of xy is equal to b, and x squared plus y squared is less than or equal to 1. And the problem 8, find b so that the above defined function is a very strong density function. So we know if f of xy is a very strong density function, the double integral of this function times dx dy will be equal to 1. And the region D is the x squared plus y squared is equal to or less than 1. So it will we can draw the region D. It will be a square. So the function, the value is b, and b is a constant, so we can put b here, and the double integral, the value the inside will be 1 times dx dy. So we know the double integral of 1 is the area of the square, which is pi. So b times pi is equal to 1. So b is equal to 1 divided by pi. The problem B, we need to find e of x and e of capital X given y, and e of capital X given capital Y, and e of y given x, and e of capital Y given capital X, and e of capital X times capital Y. And at first, we calculate the e of x. We know e of x is the integral of x times the density function of x dx. And we don't know the density function of x, so we need to calculate the density function of x first. So the density function of x will be the integral of fxy of x and y dy. We know we can note from the region D, x is between -1 to 1, and y is between negative the square root of 1 minus x squared and the square root of 1 minus x squared. So for the integral, the lower bound will be minus the square root of 1 minus square, and the upper bound will be the square root of 1 minus x squared. And the joint density function is 1 over pi. So the final result will be 1 divided by pi times the square root of 1 minus x squared. So e of x will be x times this term. So we can put 2 divided by pi here. So the integral would be x times the square root of 1 minus x squared dx. So this term is an odd function, and the upper bound is -1, and the lower bound is -1, and the upper bound is 1. So it's symmetry. for the up function, and the integral will be 0. So 2 divided by pi times 0, so the e of x is 0. And next, we find the e of capital X given y. So we know by the definition, it will be the integral of x times f of x given y dx. F of x given y is the John density function divided by the density function of y. We know this term will be 1 over pi, and we don't know the density function of y, so we need to calculate it first. The density function of y is the integral of fxy of xy dx. We can note from the region, y is between -1 to 1, and x is between minus the square root of 1 minus y squared and the square root of 1 minus y squared, because it is symmetry. So the density function of y, the integral will be from the dx, x is from negative square root of 1 minus y squared to the square root of 1 minus y squared, 1 divided by pi dx. So the result will be 2 divided by pi times the square root of 1 minus y squared. Now we have the John density function and the density function of y. We can calculate f of x given y. So it will be 1 divided by pi over 2 divided by pi times the square root of 1 minus y squared. So the result will be 1 divided by 2 times the square root of 1 minus y squared. So the e of capital X given y is the integral x is from minus the square root of 1 minus y squared to 1 the square root of 1 minus y squared, and x times f of x given y dx. So this term, we can put this term outside, and x is an odd function, so the integral will be 0, so the final result is also 0. And next, we need to find e of capital X given capital Y. We know e of capital X given capital Y is equal to e of x, and e of x is equal to 0. So e of capital X given capital Y is also 0. So for the e of y and e of capital Y given x e of capital Y given capital X, and we know the region D is symmetric. So e of y is equal to e of x, which is 0. E of capital Y given x is equal to e of x given y, which is 0. And e of y, capital Y given capital X is equal to e of capital X given capital Y, which is also 0. And the last one, e of xy is equal to e of capital X times y given capital X. And then we can put the capital X here, so it will be e of capital Y given capital X, and this term is 0. So the final result will be 0. And the question C, prove or disprove x and y are uncorrelated. We know if x and y are uncorrelated, and then e of xy will be equal to e of x times e of y. We already know that e of xy is equal to 0, and then e of x times e of y is equal to 0 times 0, which is also 0. So e of xy is equal to e of x times ey. So x and y are uncorrelated.